All right, so what I got here is I want to make me a little plate, sort of like an anchor plate for some chains that I'm gonna use a little bit later on down the road. So what I got is some clevis pins off of brake pad, brake pod chamber off a semi truck trailer, and I'm gonna use these for my anchor points. So I need to make me a bracket, and I need to be able to anchor it down to the concrete. So that's what I'm gonna do here this morning. So I'm gonna cut up a couple plates. I need 4 of them, so I'm gonna cut 4 plates out of this 2-inch, 1/4-inch steel plate here. All right, so I jumped the gun a little bit. What my plan was, I was gonna go ahead and drill my holes in them before I cut them up in little pieces. That way the mag drill would have held on that flat piece of bar, and it would have been a whole lot easier to drill that hole in there. But that's all right, we still can do it, but now we just got to do it a little harder. So what we want to do, we'll come here. Let's see what size that bit's gonna be, 3/4. Yeah. Let me get it clean. All right, so we're gonna take this mag drill and we're gonna go through here, and I'm just gonna put me a hole in this plate. I could just weld the stud on the top of it, but I want it to go through it and be flush at the bottom, and I'm gonna weld it solid. That's the way I'm gonna do it. So it's best to have the drill mounted on whatever you're going to drill, if you can. If you can mount this drill directly on a piece of steel you're trying to cut. That way you don't, if you ain't got a way of clamping it down good, you don't have to worry about it jumping around. But if you do have a small piece of steel and you want to cut it with a mag drill, you're going to have to put a piece of steel or something up under that mag drill and clamp it to be able to get the drill to engage and stay engaged. If it's not magnetically clamped, the drill won't stay engaged. So I just want to drill through the plate. I don't want to drill through my table. And normally you can listen to the drill bit when it's spinning, and you can tell when it gets out of that first plate, like if you're drilling through a double frame on a truck, when it goes through the first set of frame, normally it'll stop cutting until you get that plug out of there, and then you can go through the second frame. If it's a solid piece of steel, it don't matter, but if there's ever a gap in there, in between those two pieces of steel, that plug will go through and it'll be spinning around on the end of the drill bit, cutting head. So you have to stop the drill, get the plug out, then you can continue to drill through. And once you drill all the way through the plug will, if you got a pilot pin in your bit there, the plug normally will pop out the other side. So just say I had this steel plate up on the side of the frame or whatever, you know, if you got air hoses on the other side of it that's down in the frame, or you got a piece of electrical wire over there, rubber, that's down in the frame, you best take you a piece of something and lay over the top of it, because when this plug pops out, it's hot. When that thing pops out of there, and in a normal situation, when you got that pin in there, I don't have a pin in this one here, but when you got that pin in there to eject that plug, it'll pop out with a little bit of force. I mean, it can shoot it, 8 or 10 foot. When it pops out of there, it's got some force. So if you're drilling a hole and there's something on the other side you don't want to get burned, you got an air line over there, you don't want it to fall on it over there behind some wire where you can't get it off right quick, and it just lay there and melt down through your airline. Take you a piece of something just thick enough to keep that heat off of it, and you'll end up not having that problem. Otherwise, you're going to end up cutting an airline and having to splice it back together, because when it's coming out, it's hot enough to melt through that plastic rubber. So I got 3 of these here. I'm gonna drill the holes in them, and we'll go to the next step. This is the last one. I'm gonna show you in real time how quick it'll go through there. And that's just 1/4 inch. Regular steel. Sometimes you get on some of that hardened truck frame steel. It's a little thicker, a little harder frame. You don't try to force it. I never try to force it in there. I've drilled hundreds and hundreds of holes, and sometimes I've drilled, 75, 100 holes with the same bit before it, breaks a tooth or something off of it. And these are carbide tip angular cutters, the ones with the what they call high-speed steel. I never had any luck out of them. If they're not carbide tip, I don't even waste my money buying them. But that's it. We got the holes drilled. We got the little plates. We're gonna clean the oil off of them. We're gonna weld us a stud, cut us some studs out of these. What this right here is, this is an extra length of rod that comes on the brake chambers when you buy them new. They have, the rod long enough so you can cut whatever you need off of it to fit your truck or your trailer. So this is just some extra stuff I had. I'm gonna cut them up and save me some of this threaded rod. It's a fine thread, 5/8, 18 fine thread stud. So I'm gonna cut some short pieces, maybe about an inch and a quarter or something like that. And I'm gonna weld them up and make my anchor plates out of that. All right, so the goal I'm shooting for is I'm just trying to make this thing a little stronger than just sitting it up there tack welding on the edge of it. I don't want a big nasty finish up there at the top, but I'm gonna have some chains on here with a binder, be pulling, you know, not with a whole lot of force, but enough of force to put tension on the chain. So I'm gonna tighten that up right quick, cut another. Hammer, I gotta keep it straight. I'm gonna just tack that plate down for a second till I get this thing straight in there the way I want it. I try to get it as straight as I can. When you hit it with that welder, it's gonna move a little bit because just like anything else, when that heat touches it, it's trying to move and get out of the way from it. Just like if somebody stick a lighter up under your butt, you're gonna move. It's the heat makes stuff move. Don't matter what it is, you put some heat to it, it's gonna move. That looks pretty straight the way it is. I'll just go back and cut that temporary weld up, and I'll come back and clean it up like I want it. So, and I weld it, you know, where to have more strength up under the bottom. I don't want all that weld up there at the top gobbed up. So I'll come here. Let's see if I got a hole. I can drop it right here in this hole, just like that, and I'll weld it up. I need 4 of them in total all together, because I got 4 anchor points, so I need to make 4 little anchor plates. boots start to catch on fire. I need to get that junk back in there. I've been laying here for about a year. I need to get the bucket of water, cool it off, so I don't have to wait so long. I just go back and kind of clean it up a little bit, you know, where I tack welded that plate down. I'll grind that weld back off. I'll grind the sharp points off for the corners. I ain't a fan of sharp points. I've been stabbed a bunch of times by them over the years. I don't like them. So I need 4 of them plates, so I just do the same thing that I just did for this one. I'll repeat the steps 4 times, and this is pretty much what you end up with. I got me a nice little anchor plate. That I've got it welded solid from the bottom. I don't have a bunch of gobbed up weld up here at the top. And I'll come out and put me a coating on it, or I'll paint it, whatever I want to do. And I got me a good anchor point there. So I'll go back and make a couple more just like them, and we'll go to the next step.